Today we are going to discuss resolving vectors. Resolving vectors is one of the things that you will have to understand and be able to do for projectile motions. And the projectile motion deals with projectiles that are thrown at some angle. Projectile motion, when you're throwing at something at an angle, it is launched at some angle theta. It is launched with some magnitude. So it's launched at some velocity at an angle. When you resolve the vector, you resolve it into its components. You set it up as if it is a right triangle with the angle theta is the launch angle. So you have sine theta equals opposite over hypotenuse, where hypotenuse is your launch angle, your opposite, and then cosine theta is equal to your adjacent, so it's got to be attached to the angle, over hypotenuse. Okay, that's the equations you'll be using. We're going to look at George, and he launches a ball 10 meters per second from a 15-degree above the horizon. So this would look like your hypotenuse would be 10. Your angle is 15. And you are wanting to resolve it into the x and y components. So that means sine theta is equal to opposite over hypotenuse. So that would be sine of 15 equals equals y over 10. So that means y is equal to 10 times the sine of 15. When you do this, make sure the calculator is in degrees and not radians. So to do that, check the mode. And the mode should be in degrees. Once you do that, is 10 sine of 15 is 6.5. Make sure. Nope, I had it in radians. So now I've got it set in degrees. So if you did this and you got 6.5, that's wrong. You have it set in radians. The answer should be, into degrees, it should be 2.59 meters per second. So that is our y component for the velocity. Now let's look at the x component. The x component uses cosine. So cosine of the angle equals our adjacent over hypotenuse. So that means cosine of 15 equals our adjacent is our x over 10. So x is equal to 10 cosine of 15, which is 9.66 meters per second. So now we have the x component and the y component. Now we have George throwing the ball at 10 meters per second, 15 degrees below the horizon. So what does that look like? Here's George. And he's throwing the ball down. So this gives us 15 degrees here. And this is 10. So now we want our x and our y components. So he's thrown it down. So our first is sine theta, which is opposite over hypotenuse. So that is the sine of 15 equals, our opposite in this case is our x over 10. So our x is equal to 10 times the sine of 15, which is equal to 2.59 meters per second. So that is our x component. Now for our y. We know cosine theta is equal to our adjacent over hypotenuse. And our adjacent is our y. So that means cosine theta, or cosine of 15, equals y over 10. So y is equal to 10 times the cosine of 15, which is 9.66 meters per second.